Hello guys, so in this video, I would like us to look at numerical integration using Maclaurin series. Now, the value of many integrals cannot be determined using various analytical methods. So the trapezoidal, mid-ordinate rule, and Simpson's rule are used numerically to evaluate such integrals. Another method is finding the approximate value of a definite integral by expressing the function as a power series using Maclaurin series. So we are going to, for example, we have here, we are going to express this function into its power series and then evaluate its integral from there. So if you're told to evaluate this, so how do you go about it? So the solution, we are going to first of all start by expressing it into its Maclaurin's, by expressing it into its power series using Maclaurin's series. Now, Maclaurin series is given by, so I'm going to write it in terms of f theta. F theta is equal to f0 plus theta f prime of 0 plus theta squared over 2 factorial f double prime of 0 plus theta cubed over 3 factorial f third prime of 0 plus theta raised to power 4 over 4 factorial f fourth prime of 0 and so on. Now, our f theta here is basically the function that we want to write its power series. So in this case, our f theta is equal to exponential sine theta. The two, we can take it outside the integral sign. We will use it later. So the power series for this, let's start by getting f0. Replacing the value of 0 here, we will find that f0 is 1. Now on to f prime of theta. If we differentiate this, we're using chain rule. So the derivative of exponential sine theta is exponential sine theta multiplied by the derivative of what is inside, which is sine theta. The derivative of sine theta is cos theta. So what is f prime of 0? Replacing 0 here will give 1. Okay, on to the second derivative. So f double prime of theta is equal to evaluate this, we use the product rule. So let this be u and let this be v. Then the product rule formula. Okay, fine. So evaluating this, what is our u prime? If we differentiate this, we get exponential sine theta cos theta multiplied by v, which is cos theta, plus v prime. If you differentiate cos theta, you get minus sine theta multiplied by u, which is exponential sine theta. So what is our f second prime of 0? If we replace 0 here, cos of 0 is 1, exponential raised to power 0 is 1, so we get 1 here, 1. If we replace 0 here, we get 0 because of this, so 1 minus 0, so this will give us a 1. Okay, fine. What is our f third prime? So what is our f third prime of theta? So we want to now differentiate this function. Now I want to simplify it first. Exponential is common on both ends. So I can take the exponential outside. Here I will remain with cos squared theta, minus on this other side, I will remain with sine theta. So to differentiate this, let this be u, and let this be v, so that we use the product rule. So u prime v, so u prime, if we differentiate this, we will get exponential sine theta cos theta multiplied by v, which is cos squared theta minus sine theta, plus v prime. So if we differentiate this, let's first of all start by differentiating cos squared theta. So the derivative of cos squared theta is 2 cos theta into minus sine theta. Okay, minus the derivative of sine theta is cos theta. So the whole of this is our v prime multiplied with u, which is exponential sine theta. So what is our f third prime of theta? So what is our f third prime of 0 now that we already have our f third prime of theta? So replacing the values of theta with 0, replace 0 here, 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 here. This will be 0, 1 minus 0, 1. So the whole of this will give us a 1. On this other side, so let's replace, if we replace 0 here, we will have 1. This will give us a 1. And then, so let's have plus. Replacing 0 here, 0 here. So this will give us a 0. 0 minus 1 will be minus 1 multiplied with 1. So we'll have minus 1 there. So f third prime of 0 will be this. Okay, fine. So we already have enough terms. We already have 1, 2, 3. So we can use those 3 terms. Now, what is our f theta? Our f theta, which is exponential sine theta, the power series is given by f0. And what did we get as our value of f0? Our f0 was 1 plus theta. What is our f prime of 0? Our f prime of 0 was 1 as well, plus theta squared over 2 factorial, which is just basically over 2. What is our f second prime? Our f second prime is 1, and our f third prime was 0. So this is our power series for E sine theta. Now, if we already have our power series, we take it back into the integral. Remember, this is how our integral looked like. Integral from 0.1 to 0.4 of 2. So I'm going to rewrite the integral again. Integral from 0.1 to 0.4 of 2, can have the 2 outside, of this exponential sine theta, which is now 1 plus theta squared over 2 d theta. And now you can clearly see that it is easy for us to integrate this. So the integral of 1, that's theta, plus the integral of theta, that's theta squared over 2, plus a half the integral of theta squared, that's theta cubed over 3. And we are evaluating the range from 0.1 to 0.4. So if we do that correctly and replace the ranges, we should be able to find, so 2, replacing with 0.4 first, so we'll have 0.4 plus 0.4 squared over 2 plus a half into 0.4 cubed over 3, then minus, replacing with 0.1, we have 2 into 0.1 plus 0.1 squared over 2 plus a half into 0.1 cubed over 3. And evaluating this correctly, we should be able to get our answer to be 0.771. This is given correct to 3 decimal places. Let's take up another example. Let's say you're told to evaluate. So example number 2, evaluate the integral from 0 to 1 of sine theta over theta d theta. So the best thing is to express the power series for sine theta and then bring it back here so that you can be able to easily integrate. So our sine theta, now we already know that f theta is equal to f0 plus theta f prime of 0 plus theta squared over 2 factorial f double prime of 0 plus, which is basically the Maclaurin's series. Now our f theta in this case is sine theta. So what is our f0? Our f0 is 0. Let's find the f prime of theta. Differentiating, we get cos theta. What is f prime of 0? 1. Okay, let's continue. F double prime of theta. Differentiating this, we get minus sine theta. So what's our f double prime of 0? That will obviously be 0. Then f third prime of theta, differentiating this, will get minus cos theta. So our f third prime of 0 will be equal to minus 1. F fourth prime of theta, differentiating this, will have sine theta. So our f fourth prime of 0 will obviously be 0. Let's get the fifth term, so at least we have 3 terms. So evaluating f fifth term of theta, f fifth prime of theta, we will get cos theta. So f fifth prime of 0 will give us 1. So replacing these values back into the formula, our f theta, which is sine theta, the power series of sine theta is given by f0. So we start by writing the value f0. So our f0 is 0. We don't have to write that. Plus theta f prime of 0. So our f prime of 0 is 1. So we'll just have theta here. Plus theta squared over 2 factorial. F double prime is also 0. So we'll just go straight ahead with theta cubed over 3 factorial. F third prime is minus. So that's why I have that. F fourth prime is 0. So we leave that out. Plus F fifth prime is 1. So we'll have theta raised to power 5 over 5 factorial. So that's basically is our power series for sine theta. Now look at our integral here. We were being asked to integrate from 0 to 1 sine theta over theta. So we are looking for the integral from 0 to 1 of sine theta over theta d theta. And using Maclaurin series, we've been able to express sine theta into its power series as theta minus theta cubed over 3 factorial. So let's just write that as 6 plus theta raised to power 5 over 5 factorial is 120 d theta. And all this is divided by theta. So we've been able to express this. And now we can comfortably divide each term by theta and then integrate. So this will give 0 to 1 of theta divided by theta. That will give 1 minus theta squared over 6 plus theta raised to power 4 over 120 d theta. And now we can easily integrate the function. So the integral of 1 is theta. The integral of theta squared is theta cubed over 3. And we have a 1 over 6 here. Plus the integral, so we have 1 over 120. The integral of theta raised to power 4 is theta raised to power 5 over 5. And we're evaluating from 0 to 1. Now we first replace the values with 1. Replacing with 0, we'll have a 0 all through. So replacing with 1, we'll have 1 minus, that will be, replacing with 1, that will be 1 over 18, plus replacing with 1 on this other hand, or on this other end, that will give us 120 times 120 times 5 clearly. So that will be 600. So we will have 1 over 600 and so on. So this is going to be our answer after we evaluate correctly.